first of all, about me, I have multiple hats, and one of them is federal government, actually main one. So my view are not represented, views of Army Corps of Engineers. And I try to, and the other has is obviously I'm a joint professor in multiple universities, and my background is in quantitative science, physics, but I kind of progressively moved to social science. And I think for us as management, this is kind of your community. This fusion is really important. And resilience for me is all about fusion of physical and social science and reconciling it in the context of individual assets and a system of assets, portfolio of assets. So the best way to visualize it, actually looking at what happens historically. And this is a slide from Dallas-Fort Worth Airport, and you can see here in red temperature. The temperature dropped and airport stopped operating very fast. It's very correlated with the temperature. And then temperatures start to go up and airport recovered within a day or two. And, you know, everything get back to normal, right? So that was a dramatic event for Dallas-Fort Worth, which is one of the largest airports in the world. I think it's in top 5. It's of the size of Manhattan. And they identified the problem. The problem was that they are prepared to deal with snow, but ice events. So they invested $100 million for the icing fluid to get additional equipment to deal with ice and snow. You should see, if you drive in DFW, you can see like literally 2 dozens of big snow plowing machines and all that. So they thought that they are done, but this is what happened in 2021, 10 years later. So what you can see on the bottom is that temperature drops, and you know, amazingly, airport keep operating, right, for 5 days. But then something else happened, and airport operation now paralyzed basically for the whole week, right? So what is the message here? The message is that what $100 million investment bought, they basically hardened like one type of assets, ice removal. But what they didn't do, they didn't harden energy system because what happened here, it was energy issues, and once energy get down, airport was down for the whole week. So from point of view of risk management that is focused on individual assets, they succeeded. This assets that primarily responsible for failing before is now fixed and works. But at the system level, they didn't fix resilience. So this is a long way to say that in managing assets, we often approach it from risk point of view when we look at this complex system with multiple assets to manage, and we pay attention to probability of failure of individual assets. While in reality, you need to think about balancing this assets level approach with system level approach. And this is what resilience is for me. So this presentation, I try to structure it along the line of further exploration of how risk and resilience are connected, how to measure resilience, how to balance resilience and efficiency, because obviously there are clear trade-offs, and whether you do resilience by design or resilience by intervention. So first of all, risk versus resilience. I think it's of crucial importance. When we talk about risk, this is from Oxford Dictionary. We talk about dealing with threats or exposure to these threats, and risk is a product of threats, vulnerability, and consequences. What is important, there are many other concepts related to risk, like security. If you manage to Uh, uh, if you manage to deal with your threats or vulnerabilities, you harden your system, you achieve state of being free from danger or threat, right? Reliability is, you may have some small fluctuation of your performance, but fundamentally you're not going down. But resilience is very different. Resilience starts from system is already down, right? Resilience is capacity to recover quickly from difficulties. And it's
Yes.
visualized in this slide. Um, if you talk about risk management, you start with system functional, and you don't like this functional to go down. You either shield system from threat or harden it to make it less vulnerable. But fundamentally, your starting point is functional system. Well, if you talk about resilience, you basically in this inflection point too, you have system that is already down, and we are not necessarily know what make the system sick. You know, the best example is like when we get sick, we usually don't know what kind of virus or infection or what happened. We have symptoms, and when you have symptoms, you are not necessarily trying to figure out exactly scenario that make you sick. You try to, you call physician and you recover, he or she tried to recover you based on dealing with these symptoms and using logic model about, how to best deal with this combination of symptoms. But in a sense, it's, if you think about assets management, is the same idea. If system fails, you don't know what combination of assets resulted in that you need to recover. And when you design system to be recoverable, you need to think about what combination of assets you need to harden, not necessarily the best performing or best vulnerable assets, but rather combination of a few of them. So I think it's very important that risk and resilience are different. And this again, risk is just one point on this curve, while resilience is more connected via under the curve of loss. So, and it's reflective on how we assess risk. Risk science traditionally emerged with this quantification based on absolute units, right? Risk can be expressed as a probability of something bad happening, the probability of getting disease or probability of recovering, things like that. What happened now is we actually moving from the idea of expressing risk in absolute unit to the idea that we can track a few metrics. So in a sense, now we move to the area where risk is perceived like threat in the, not necessarily units, but rather multiple metrics that we are tracking. What is the problem with risk management, especially in the case of complex and interconnected system? The issue with risk is, as I mentioned, you need to prioritize threats or vulnerabilities, and you need to deal with them one at a time. If we go to low probability, high consequences event, it's getting to be more and more expensive to manage. The example that I'm using is my agency, Army Corps, is building seawalls, and it's reasonably cheap to build, reasonable size of seawall, but every additional inch costs exponentially more than previous few inches. So what's happening is, and it's visualized here, that if you increase investment on the x-axis, you're buying down less and less risk. So you're getting marginal return for your investment. So then the question is, what are they going to do with that? And this is where resilience comes into the play. Resilience allows you to kind of accept residual risk and say, well, we are going to buy down what is reasonable and cost efficient, but then we invest in adding capability to recover. One of the first documents from government, obviously resilience in academic discipline was around a long time, but massive attention to resilience in government started in 2013 with Obama's executive orders on infrastructure resilience, and it was kind of exponential increase, and Trump administration used resilience more in the context of cyber, but then after COVID, everybody realized that resilience is something that we need to really worry about, and it's now resilience is all over in all discipline. And currently, I'm part of several committees on the White House, National Security Council in the US, and others, developing a new resilience strategy document, and I think it's more is coming. My worry, though, is that resilience may become a buzzword similarly to what happened to sustainability. Sustainability is more like a goal, something that we need to achieve. Everything is good. Sustainability is always good. But in reality, the problem is that we cannot really measure sustainability. There are no common ways to assess how whatever plastic bags are more sustainable than paper bags, because they both have benefit and associated risk. And often what I see, we use green materials and then it means that we are more sustainable. That's not necessarily the case. If you start to use wooden forks, as airlines start to do now, I don't think that this is like making you sustainable. You're killing trees. Well, if you use plastic, you have other problem. You pollute environment, and but then to develop energy and to clean environment, you need trees. And anyway, I don't have time to go through that, but you get the message. So early enough in my exploration of resilience, I started with the idea that we need to measure resilience to make it operational. And this slide shows the two most general way to measure anything, including resilience. You can develop individual metrics, and you can manipulate these metrics, right? You can connect them in indices, dashboards, and probably one of the most advanced way of doing that is decision analytics framework, when you connect metrics based on value system of decision maker, and you have not just dashboards, but rather weighted and way to present values of different alternatives as utilities and measure them as utility functions. On the other side, you have model-based approaches. You have process model, you have statistical model, networks model, game theoretical simulation. I present a few slides on network-based models that we used for supply chain and for transportation. But for me, that's one way of doing that. So to start with metrics-based model, we introduced the concept of resilience matrix. Basically, the idea here is that resilience is system properties. So you need to connect, you need to get metrics of all components of the system. And in more general way, system is composed of physical, cyber, cognitive, and social domain. And this is taken from network-centric operation doctrine that US military developed. So what we've done, we use these domains of the system and overlap it with this resilience cycle that is defined by national academies and executive orders in the US, but in Europe it also similar. You have this absorb, recover, and adapt. So you have critical function, and then you drop it. That's where absorb is, and recover and adapt. And once you do that, in a scalable way, you have something like this when you have a matrix, and once you assign weights on the cells and connect individual metrics, you can use it to evaluate different strategies. In your case, it's assets management strategies, right? You have current system performance as baseline, and then you can have two different portfolio of assets that you like to invest. One of portfolio costs a lot, but it increases resilience a lot. Another costs less, but it may increase resilience enough to be above threshold of performance that you like to achieve, right? So I think that's basic idea here. And what you have as unit and y-axis is like this unitless utility scale that you can assess specifically for your system. I don't have time to go through that, but we kind of conceptualized it for energy and cyber. We have a large project now when we try to apply resilience at watershed scale for Army Corps operation, but we also apply this in manufacturing and other areas that may be closer to assets management needs that you may have. I'd like to say a few words about resilience, network-based models. So the idea here is that, complex system, including assets-based system that you're dealing with, may include individual assets connected in network, and resilience can be assessed as a property of network structure, links, nodes. And once you do that, you may be able to assess recovery of the system if individual assets are disrupted. So that's kind of what we've done in several projects. I'm going to present transportation here, but we are working on very large project in supply chain, which I think I have one slide towards the end, and manufacturing. Those may be areas that can utilize the same approach. So in the context of transportation, we try to think about resilience, which is ability of the network to recover from disruptions, major disruptions like major accidents or floods when some of the roads are out or things like that. While, of course, we can talk about the efficiency of transportation network. Basically, if you have a lot of cars, a lot of traffic, and you are stuck somewhere, your network is not efficient. But there is a fundamental difference. When we talk about efficiency, we usually deal with normal disruption, something that happens every day. So, for example, I know that it takes me 30 minutes to get to my office without traffic and 45 minutes with normal traffic. But what happens is that I know that, and I am not I'm not scheduling any important events within like an hour from my departure from home. But with resilience, I cannot predict what is going to happen. So you can intuitively feel that cost of efficiency and resilience may be very different, and efficiency and resilience may be different for different networks. And kind of this study shows that what we've done, we developed resilience model for transportation, we connected with economic models, and results are quite interesting. So that was our first paper on this. We look at 40 cities in the US, and you can see that San Francisco and LA equally inefficient, a lot of traffic. If you go left, it means efficiency is low. But LA is very resilient and San Francisco not. Why? Because if you know US, LA has a very irregular grid of roads. It's kind of newer development in a flat area, while San Francisco had water, bridges, it's a more historic place. So if you're stuck in LA, one road is out, you always find a way around it. But if one of the bridges in San Francisco is out, or one of the stretches of the highway, you are stuck there for a long time. So that's kind of, again, intuitively illustrates what you see here. And back to what I said, the cost of inefficiency and lack of resilience is really different. Resilience are more expensive. Lack of resilience are more expensive than lack of efficiency, and it's shown here. And it's very nonlinear. So you can think about that in the context of assets in the same way. It's very nonlinear processes when you start to think about the ability of system to recover. So a couple of other highlights of our research, and I probably need to finish to give Gianluca some time. We talk about whether you can build resilience in the system or intervene. And by intervention, we mean bringing resources outside of the system. To make system more resilient, it may cost a lot of money, right? Simple example, you can have a generator at home all the time, and you can use it like, once per year. So it's very expensive investment. Moreover, it's not just cost of buying generator. You need to maintain it. You need to check whether it works or not. So it's not just cost that you need to pay upfront. It's maintenance cost, time that you spend on that. And again, it may be there are many examples when this redundant capacity that you build in the system doesn't work when you need it, just because you did an exercise. So in one of the cases, the person who knew how to operate it retired, and we were unable to do that. Intervention is different, right? If you can survive energy blackout in your house for a day or 2 days, you can have a contractor who can come and bring you a new generator or fix what you have. You can establish contractual agreement with somebody who can help you to do that. Or you can buy insurance. So again, this is the difference about you designing your house in a way that allows you to deal with disruptions versus you buying something else to help you to get through that. And depending on your tolerance for blackout, depending on your criticality of energy for you, it may be a different solution. If you just residential house, yeah, you may survive without electricity as long as you have batteries, you have a generator. But if you're military installation, so industrial lab, you may lose a lot if you have energy shutdown even for a few seconds, right? So that's how we deal with critical functionality. Resilience only makes sense when you understand what is critical for you. Another way of dealing with resilience, and I think Gianluca will talk more about that, it's stress testing. The idea here is that because resilience is about interconnectedness of your network with other networks, and we deal a lot with cascading failures, you need to stress test not only the network that you're managing, but also network that influence your network. You need to stress test connections of your network to other sources. So that approach was developed for United Nations, and both me and Gianluca contributed to that, and they use it now in multiple countries. And what we do now, we try to apply it for asset level situation. We have a large project with a major airport. When we try to really look at assets, we build digital twin of the system, and we implement stress testing with the idea to understand which assets are more crucial for performance of this system, like airport in this case. But you can apply it to whatever system that is under your management. And obviously, I cannot talk about anything these days without artificial intelligence, and especially for assets management. Digital twins that integrate multiple assets is a really future for me, that you can build all this advanced analytics stress testing on top of digital twins and improve assets management. But obviously, the problem with AI is that, can you trust it? And again, this is another line of work that we have about resilient AI, when we try to see through stress testing whether AI predictions can be trusted, and whether changes in your environment and your assets configuration would result in different AI prediction. If this is the case, predictions are not resilient, right? And we apply it for self-driving cars. And as I mentioned, we do a lot of supply and demand networks. And this is a DARPA project where I'm working on. It's actually designed to really develop risk and resilience visualization and stress testing of these networks. And we use AI to supplement what is available from data-driven methods with AI-enabled tools with generative AI to really add additional supply chain component that may not be available in existing database, and maybe too expensive to buy. So, and again, this is just one slide. We look at the whole transportation network in California as a system, and we integrate these areas, ideas to really look at assets that they need to maintain and manage. Okay, let me stop here. And I don't know if you'd like to ask a question now, or if Gianluca is going to present and questions later. I don't know what design is better. Can you hear me still?
Yep, we'll hand over to Gianluca and we'll take some questions at the end. So, Gianluca, over to you.
Can you hear me? Can you see me? Perfect. So first of all, apologize everyone for my technical difficulties. I experienced one of the things that happens often. So getting stuck with technology. Reality is that resilience is something complex, is something multidimensional, and we need to start from the very basic things. So something like having a backup. Now I'm talking with you from my laptop instead of my working Mac, and understanding the role of relations, the role of trust, and how can we understood and operationalize resilience, investing on people, on procedure, and not just from time to time the easy solution that is just having something, a new technological tool that is going to be brilliant, but maybe going to stay there on the side. So I work more on how to keep organization running and introducing this idea of resilience and how we can practically leverage even basic learnings that can spread and support our operational capacity. So we know that our operational context changed in the last 20 years. We passed from a situation where first response was focused on assuring the basic need to an operational context where we are reliant on services and critical infrastructure from energy, Wi-Fi, international and interconnected networks, and this focus is now considering compound and interacting risks, so two things happening at the same time, such as cold weather happening during an heat wave, during a coronavirus, or space weather events happening when there is another emergency going on, like flooding. The reality is, though, that without the technological backbone of what we are doing, without the capacity to acting on preventing and mitigating disruption on the technological side, whatever we are going to do is going to be at risk to get stuck. So systemic risk now is a reality that we need to deal with. So we need to consider in our planning process, in considering asset management, what are two or more successive events happening at the same time. We need to consider cascading risk, that is the disruption of critical infrastructure and tightly coupled system. We need to consider interacting elements like an earthquake triggering a tsunami. So systemic risk is complex, but a systemic risk can be operationalized. Just as a first step, considering that disruption can happen, and when we think it will never happen to us, we are lying to ourselves. So in this new context that we are living now, considering also the global uncertainty, what is happening worldwide from bottlenecks that can be triggered in the Suez Canal, to the possibility of an escalation of geopolitical issues, to the possibility of a climate extreme happening, creating new situations that happen at the same time. History is full of worst case scenario. So low probability event, the recombination of all these together doesn't mean it won't happen tomorrow. So systemic risk, understanding systemic risk requires to bridge what we are considering as emergency planning and management. Now, with organizational resilience, climate change adaptation, and in your case, in asset management, bringing resilience to what you're doing. So applying the tools that Igor explained you to what you are doing since the planning phase. So we are now developing a new methodology of stress testing. This is done on the work that Igor principally did at the United Nations with the United Nations, and our new project called Agile, an approach that tries to be risk agnostic. So I'm never going to tell you, be specifically ready to this kind of risk, this kind of threat, because it's not the way we can operate in the future. The way we can operate in the future is kind of like being ready to things like what happened to me during this webinar. Disruption happens. It's not going to be necessarily just the laptop failing. It's going to be maybe the internet connection. It's going to be maybe denial of assets in the building. The point is understanding what are the common point of failure between these threats to address resources there, develop a prioritization of what we need and where we need to address what we do, and go on in the assessment. So we are going to do that in steps. As a first part, as a basic level, we need to consider scenarios that bring together single hazard, then two things happens at the same time, then cascading effects, for example, power failures, disruption, blackouts. What are the implications for your asset, your services, how you're going to mitigate the risk and plan for the long term. In this phase, that can be done just with tabletop exercise. Often, my question for you is, do you think are doing well the basics? From time to time, the core problem may be just missing some procedure that are going to allow the different departments you are managing to talk together, to interact together. As a second step, then we develop a semi-quantitative approach to stress testing. And as a final way, what Igor was explaining you of a quantitative assessment to resilience. So I'm keeping it a bit short to get questions in particular. I'm sure that you're going to have a lot of things on what Igor was saying. When we think how to develop our sector, how to develop and interact asset management in the future, the core point is that we can deal with low probability impact events. We can deal with scenario we are not planning for, we are not considering, because they are not something we experience until now. This is going to be our new operational reality because of climate, because of the interdependencies associated with networks, because of cascading effects and failure that are unpredictable. So we need to shift our mentality from thinking to the triggering event. So what is the punch that comes in our face, to how our body behaves, how your asset behave, identifying possible escalation points, adapting our scenario, our strategies and our procedures, modifying strategic training, and facilitating cross-sector communication. Using stress testing to understand where redundancies are more important, when there are common points of failure that can trigger an escalation of the emergency, that can disrupt all your system. And at that point, we need to integrate these in practices of organizational resilience. So depending on where you are, what is your reality, you need to consider how to best act, prevent and prepare before you get disrupted. So your context, the reality maybe in Bristol is going to be different than the one in London. But also try to understand what in continuity management are the most critical sector after which everything is going to follow as a consequence. So prioritizing where the networks are concentrated. Starting to think about the different components of scenario of seasonality, time, location, but also what of the element that you have in your system and asset are cross-border and how to address them. So shifting in planning and preparing from approaches that are oriented what we are going to do if that specific risk or threat happens, to resilience, to create resilience in your organization. So moving toward one low probability impact event is rare maybe. However, if we consider multiple of these kind of scenarios, we are going to identify, we are going to be able to address resources where it hurts the most, where we are going to see that these point of failures that are common can be triggered, and so addressing their resources, planning capacity, and thinking in medium long term to change the way we do it. It's very important for me that whatever you're going to take away from this event is considering where asset management can interact with the other sector of your company, of your system. So resilience, sustainability, how can we work together toward doing something in the direction of what Igor was saying earlier. So I will leave the last 10 minutes to questions, and I hope despite all the technical issues I had, what I said was clear. I hope that you were able to see my slides. Otherwise, the point is consider carefully how we can be more efficient in what we do and how to apply what Igor just said to these new operational scenarios where disruption are going to be business as usual. And I will say I will be happy to take any questions on this, and I hope Igor too is going to be available. The importance of training in resilience. Any questions?
Thank you very much, both. If anyone has any questions, you can pop them straight into the chat. Should be on the right-hand panel, the little bubble with the question mark in it. Pop them in there, and then I can ask Gianluca and Igor for their responses. Whilst any of those come in, oh, we do have a question. Okay, someone asking if they type the questions. Yes, if you can type the question into the box. Here we go. We have a question for you. What is a low-hanging fruit for asset-owning organisations? That may not have jurisdictions, BIA analysis to improve resilience, BCP, standards for stress testing. Hopefully that means more to you than to me, but yeah.
Maybe let me start and Gianluca will finish. Actually, business continuity is something that most of the organization is already doing. But if you think about that, business continuity helped many companies to survive through COVID. But you know, 2 years later, many of them are going through bankruptcies. Why? Because you have business continuity, which allows you to deal with temporal, short-term temporal disruptions with 1 or 2 assets, but these complex systemic changes that happened after COVID did not allow companies to survive. So back to your question, you need to think about how to transition from risk and business continuity towards which are kind of individual assets level towards system level resilience considerations. So that would be my advice. Gianluca, maybe you have more.
Yeah, so one of the things we suggest is, first of all, you can use this approach to scenario and stress testing, in particular the tabletop exercise, to bring together and understanding the different cultures that there are across your organization to create something common toward resilience. So what is going to happen, at least to my understanding, is that in many organizations there are a different way to do things and different way these problems are approached. So coronavirus was quite useful if between all the problems I created to develop a culture that we need to do continuity management seriously, otherwise we were not here speaking with you. However, this is just some of the principle of what we are going to experience in the next years, unfortunately. And it's not to bring a bad luck to the room, but we need to be aware that between climate extreme, geopolitical situation, and the increased dependence on technology, we are dealing with a reality that is complex, and we are going to deal with disruptions. So if you are thinking about what are the low-hanging fruit in terms of measures that you can develop to move forward from the situation you are, is try to use tabletop exercises to share the understanding that of how this event can become complex and how this event can involve at the same time all the different parts of your company or your business or your organization. So when you do that, you can create the culture that is needed to do exactly what Igor was saying, to moving toward resilient thinking. Thing that I'm trying to do with Igor and also with United Nations is start to consider how we may have to need to restructure companies thinking to bring resilience above risk. So using resilience as a chief resilience officer that some company has already as an overarching figure where you can connect all the components from asset management to sustainability into a strategic view to move forward the company. So from steps, easy win, bring everyone with a tabletop exercise to consider how the operational situation is changed and how we can work better together. Create the culture, bring resilience at the company level as a third step. I hope it makes sense.
Thank you. We've had quite a few more questions come in now as well, so that's good. So we've someone's asked, any thoughts about integrating stress testing into ISO asset management or resilience standards?
Igor? Well,
we don't have stress testing standards. I think the only one, no, I don't think we do have. Maybe industry, but it's different. If anybody likes to take the lead, that would be great, but that should be done, because stress testing for me is the way to assure that your system is resilient. It's kind of sandbox environment that need to use to test your investment in assets management, in a sense.
Yeah, I think this is a great idea. I was in the committee that was reviewing the BS 65,000, just to join it at the end. Definitely, if I will be invited again in the next review, I'm going to push for this, both in ISO 22301 and the one on resilience. So I think we are starting from the finance sector. So in the finance sector, stress testing is already mandatory, as we know. It started with the legislation of the Bank of England, but I will definitely push whenever in the next committees I'm going to be in to have this as a part, or less mentioned within the state standardization process. We can actually propose it to our colleagues on the UN. So the progress that there have included, for example, the new standards on infrastructure resilience. But I believe that what we are doing within this project, within this collaboration, needs to be streamlined. And for example, I'm talking with different companies in the groups I am to consider these and consider one in the next years, less for the early tires, or less from the tabletop exercise. This is a very easy win. It's just another way to do what is already done in a fragmented way. So recognizing the problem associated with cascading effect, systemic risk, concurrencies, so multiple things happen at the same time, disruption that are falling down and are not so predictable within the tools we have already, and then scaling it up. So we are having this conversation, and if anybody of you is in the review standard, yeah, then more than happy to help you to try to streamline this in ISO standards or British standards. Igor, maybe it's worth for you to have also a conversation with an FPA.
Thank you very much. So we'll just get through a couple more. So we've been asked, is there a lowest effective dose approach that agencies could take towards resilience? It seems like we may be over-investing in risk to prevent and not enough on resilience measures.
That's exactly what I'm trying to convey. But unfortunately, the current regulatory structure, at least in the US, is built around risk management, and agency do what they believe they're getting money for. So again, don't quote me on that, but my agency, Army Corps, we believe that we're getting money to buy down as much risk as possible. So if I get $100 million to build the seawall, I will invest every penny to build the highest seawall I can. And you know what is going to happen. And moreover, I do it in the cheapest possible way. So, but you know that we're still recovering from Sandy and Katrina, which are decades. Why? Because that's how we build infrastructure. It's efficient, it works up to the level that we set it to work. But if you have storm of high intensity, you have catastrophic failures because the system are not resilient. If they fail catastrophically, and that needs to be changed, right? Instead of building seawall that is going to take 170 years flood, I will save a lot of money by making it ready for 150 years old flood, but make it in a resilient way that it doesn't catastrophically fail, but you have degradation that it's easy to fix after that, right? So that's idea, but we need to do a lot of regulatory developments before resilience become the concept that people can use. But back again to my point, the key is to be able to measure resilience, right? Because we're talking a lot about sustainability, but I'm an agency of engineers. I cannot include sustainability in my optimization algorithms without being able to measure it, and resilience the same.
Yeah, I'm gonna top up with something that can be unpopular in certain audience. When we speak about risk agnosticism, okay, we don't deny the importance of doing risk assessment, risk mitigation measure. However, we need to be realistic on how we can react and how can we prepare to what we are not used to predict, or because of the historic series we were considering are not the same, or simply because our understanding of the operating system is different. I'm a simple guy, okay? I have strange hair today. I'm in my office at university, so I look like a mad scientist. But my last job before coming to UCL was becoming a baker, okay? Well, I was working in a bakery 10 p.m. to 6 a.m. So when I think about this thing, I think what can I be helpful to the people I was working in a bakery or I was doing security with all this stuff. The idea that I found more effective is the point we use in martial arts. Okay, I've been doing martial art half of my life. Common mistake is focusing on the idea of what you're going to do when you're going to get punched. So, oh, somebody's punching me, I'm going to do this, I'm going to do that. But that is the opposite of how it works. The more experience you get, in particular, if you do try the traditional martial art, the more you learn a pattern of movements that is going to help you independently what it counts. It's going to help you adapt and react and counterattack independently of the situation. So the same movement in traditional martial arts, we say, is the same one that is going to help you sticking a nail in the wall. It's the same principle of hitting. So changing this behavior and bringing it to an organization implies that some of the measures you need for activating and be resilient are very basic. Okay, they don't require a lot of resources. They require a shift of mindset. This is a pros and versus. On one end, you require less resources. On the other hand, as a shortfall, you require less resources. What I mean, that you need to be very careful how you are selling it. If your CEO, your boss, want a shiny measure, like a dam, like a dike. And you're proposing, well, maybe what we do is also something else. It's gonna help understanding that maybe we need to build a bit far from the coast. We need to be ready and understanding how to deal with the water. The effect can be different. On the positive side, working on this constant change is going to give us, on the longer term, much more possibility to evolve. So I hope it makes sense. And again, it's very practical. The first thing you need to do is start to assess what are the measures you can do between different things you're preparing for.
Okay, thank you very much. We have 3 more questions. If you guys are okay for time, we can continue with those, because yeah, okay, this will be the last 3. But someone's asked, we've just passed plus 1.5 degrees and are designing buildings for a 60-year lifespan. What does your stress test tell you about design standards?
We have not applied to individual buildings, but it can be done. Again, we actually have very interesting project when we look at mold formation on buildings and connecting of mold formation to different factors like HVAC system, humidity, and all that. So, I mean, we have not done it. I don't know, Gianluca, if you have any thoughts on that.
No, but when I was developing some of these things, so the story of what is Tier 1 stress testing in the model that Igor was showing is basically related to all the work I was doing with London Fire Brigade, London Resilience, on the cascading effects of power failure. And in this, we were considering also how to deal with this specific topic. Look, we didn't run it specifically on building codes, etc. But I can tell you one thing. If you apply the methodology that is based on tabletop exercise, okay, again, but this tabletop exercise, compared to what we are normally using to do, is start to introduce the pattern of what is going to look like, or the adaptation pathways also that I know some colleagues developed, for example, from the environmental agency, okay? So you go one, first implication, heat, cold, and see what happens in concurrency. Normally, in terms of building code, what you're gonna see is you're gonna discover where the building codes need to be interacting with other elements within the urban asset, in the urban environment, that instead are not interacting with. So what you're gonna see there is not, unless for the Tier 1, maybe it's not the structural problem, but it's gonna help you understand where you need to synchronize the system with what you have around. The first time I had this conversation was actually quite far ago, before we formalized the idea of tiered approach to stress testing. It was 2019 for the Borough South work, because they were talking about the new developments, etc. And I believe that if you approach this problem in a very practical operational level, so not expecting, unless for Tier 1 and this kind of tabletop exercise to find the moon, but expecting to find a hole in the road in front of you that you didn't see, or you didn't understand how deep it was, this is going to help. I hope it makes sense.
Thank you. We've also been asked, given the highly complex nature of infrastructure systems, do you have suggestions for how to go about developing the measures to characterize system resilience?
Yeah, we do a lot of work on that. As I mentioned, we have a project that probably will change the way Army Corps manages resilience in watershed scale. We're developing system of interconnected infrastructure and watershed based on community preferences. The key is that you may have multiple metrics, but you need to prioritize them in a way that is reflective of critical functions. that community care about, because for a long time we were looking at what makes sense from engineering solution point of view, but some of our solutions were not necessarily important for communities, right? So that's a big field. We can, I can provide more information how we do that if you send me email. Thanks.
Yeah, I mean, Igor is actually my mentor in the US on this. And if you need this kind of thing as a first step, write him. I can tell you what else I'm doing. For example, I'm collaborating with the United Nations for trying to release as soon as possible some universal KPIs, okay, performance indicator for resilience. These were thought speaking with the chief resilience officer from different multinationals. And we are going to try to have a common benchmarking that can be replicable across the supply chain. I was expecting this to be out already, but we are actually piloting with a system of one of the partners of that project, and hopefully it's going to be available in the next month, and we're going to forward it on LinkedIn. So if you're interested in that, please connect and please use it and test it. Again, you need to also to consider that you have different levels in which you can work. Okay. The more complex you get, the more models you need. So if you take as benchmarking what Igor was saying of the different steps, the different tier, if your organization is not ready, you don't have necessarily to go with a more complex solution. You can start with the basics and use it to change the culture there, or even just starting to understand the network in which you are interacting, because often we are overly sure, call it like that, about first-party provider, second-party provider, third-party provider. If you're not in a bank already when you're arriving there, it's complicated. So starting to use these tools and these KPIs to move forward again for steps, not expecting the moon immediately, but building constantly for a change. And I hope this is clear. Happy to connect on LinkedIn, or if you have any question on what we were saying, happy to meet in person if you are in London. Trying to bring Igor here to Europe as soon as possible again.
Okay, thank you. So we'll just finish up with one last question. All of this will be available after the webinar within the next week or so. They'll become available online, the recording here of all the presentations and all the questions. So our last one is, can you give specific examples of metrics that are useful for evaluating resilience in the context of emergency or critical facilities?
Yeah, one of the traditional type of metrics related to time to recovery, right? How long does it take for you to recover different functionalities? You know, it may be, imagine that you have disruption in energy system. How long does it take for you to call a contractor and get it fixed if it's like minor? Or how long does it take for, you know, your energy provider to do that? You can look at historical records to kind of get that. Now, if you're talking about supply chain, again, you may have, if it's related to transportation, you may have delivery time, you know, how, you know, usually FedEx delivered in 2 days, but how much of delay can happen, extra couple of days, right? You can build distribution based on historical records, but I mean, resilience is all about time to recovery and ability to recover. So it can be more complex system of metrics that not necessarily have a time dimension, but you know, it might be if you have how many generators do you have in the building? Obviously, if you have 10, it's really good. If you have 1, it's not good. But it depends on the critical functions. These metrics may be important for hospital, but if you have 1 at home, it may be more than enough. But 1 in a big hospital may not be enough, right? So you can get the point that number of generators isn't a metric, but the threshold that you need to achieve may be different. Anyway, again, it's very good questions, and There are no library of metrics for resilience yet, though it should be, but we are moving in that direction.
Yeah, I can thank top up. Part of what we need to release with UN is going to be this KPI that are exactly part of that. It's going to help you to understand across 3 levels where you stand. And these are derived from the experience of our chief resilience officers. Other things you can find online are, for example, we published a couple of guidelines in the past on space weather, organizational resilience, cascading effect of critical infrastructure we are doing with our stakeholders in the public sector out of this, and you can still find them online. I also published in 2020 a very small scale, 0-3, to help doing the benchmarking. So as Igor is saying, you need to consider very carefully what is your organization, what is the universe in which you're operating, because what you need may be different. So I guess even in this call, if you are from different sectors, your priority and what you need to consider in that assessment is different. But the way you can benchmark capacity to what you have is the same. So I can also send these documents if you want to contact me on LinkedIn. I'm happy to help.
Okay, all that remains is to say thank you very much to Gianluca and Igor for your presentation today. As I've stated, the whole recording will become available, so anybody can watch that back. Yeah, thank you very much both for your time today.
Thank you very much.
Yep. Feel free to contact me if you have questions. Bye.
Definitely. Please get in touch with LinkedIn whenever you need. If you're in central London, pop in for a coffee. Best coffee machine in the whole center.
Thank you all.
Bye.